A truss consists of horizontal members AC, CD, DB, and EF, and vertical members CE and DE having length L each. The members AE, GE, and BF are inclined at 45 degree to horizontal. For an uniformly distributed load P per unit length on the member EF of the truss, the force in the member CD is. So we have given a structure of a truss. It has horizontal members as well as vertical members, and each member have length L each, which is length L each, and AE, DE, and BF are inclined at angle 45 degree. Okay, and there's a uniformly distributed load P per unit length uniformly along the member EF. So what we asked you is to find the force in the member CD. Okay, so the very first step is we have to find the net effective force from that uniform load P. We know they have already given P. There's a uniform load of P per unit length. Okay, unit length the P load is acting for. So for a length L, the net effective resultant load along that uniform region will be P into L. So among the uniform load, there is a net force of P into L is acting downwards on that member EF. Okay, so first we got that net effective force, that is PL. So now to solve this problem, we have to apply the basic equilibrium law. By law of equilibrium, first by force equilibrium, by applying force equilibrium, considering the vertical reaction, we know there is a roller and hinge is given. For roller only there is a vertical reaction, but hinge there is horizontal as well as vertical reaction, but there is no significance of horizontal reaction in this question. So we will be taking both vertical reaction of both roller and hinge. So R and RB be the reaction at the roller end and hinge end. So by applying the vertical equilibrium, RA plus RB, it's on the same side because it's both acting upward, and the only force acting downward is the net effective force P into L, right? So that is downward, so RA plus RB equal to P into L. Take it as equation number 1. So next, by law of equilibrium, first we apply the law of forces, then moment. Moment is balanced. So suppose I am applying moment about A. So if I apply moment about A, that RA will not be come into effect because there is no distance, perpendicular distance. So the only force is P into L and RB. So RB into 3L, total distance from A is 3 into L. So from the distance of the point B from A is L, 3L, L plus L plus L. Each member is length L, so total distance 3L. So it is acting anti-clockwise about A. So suppose I take anti-clockwise direction positive, I mean taking one sign convention. So RB into 3L, and other force acting is PL, net effective force PL, which will be which will be exactly at the middle of the uniform load. So when I take that force along, extend to downward, it will intersect exactly at the middle of this whole length AB. Okay, that's why that distance is 3L by 2. Okay, from that point along about the point A, that distance will be 3L by 2, right? Because our uniform load is acting exactly at the center. So RB into 3L minus PL into 3L, because that's the opposite direction to the moment due to RB. Okay, so RB into 3L minus PL into 3L by 2, which will be equal to 0, right? Moment about that A will be 0. From that I get from this two equation 1 and 2. From this two equation 1 and 2, I get RAS PL by 2. Next, consider the point A. If I draw the force along the point A, AE is there, AC is there. There's a vertical reaction RA which can be extended upwards. So we know that RA is the vertical component of the force along AE, sine component. We know that angle is 45 degrees, so sine 45, FAE sine 45 will be RA, right? Similarly, like force along AC will be FAE cos 45. So that from that two equation we can find FAC as PL, because I know FAE, we know RA, RB, so I get FAC as PL. So considering the length CE and AD, CE is perpendicular to AD, right? So there is a law of in engineering mechanics that if three links are joined, the link the one which is perpendicular to other two link in linear. Here AC and CD are linear, right, along the same line, and the only thing that is perpendicular to both is CE. So the force along CE will be 0. That is the law of mechanics. If three links are joined in this arrangement, so we got CE as 0, and looking, we know the each length of all the members are same, so FCD will be FAC. Okay, FCD and FAC will be equally distributed, as FCE is 0. So as we know FAC as PL, so I finally get the value of FCD as P into L. So the answer is P into L. So all I have to know is the basic law of equilibrium and the law of this link. I mean, if three links are connected together, the one which is perpendicular would have 0 force, and other two will be equal. Okay, that's other law of mechanics.